Welcome to the AdaptoFlow midterm report demo for TrialsNet Open Call. The AdaptoFlow's innovations include the introduction of a service that supports AI/ML inference and data stream processing for geo-distributed applications, like Use Case 1 and Use Case 4, by adapting the execution intensity at runtime. Adaption based on evolution of IoT data and the state of the underlying computational resources in order to maintain the quality of service requested by application operators. Rapid and reproducible benchmarking with mixture of physical and emulated experiments. Upgrading TrialsNet use cases for smart crowd monitoring Use Case 1 and traffic management Use Case 4 bound to the Romanian testbed. In the AdaptoFlow project, we propose two modules, namely, adaptive stream inference that monitors the behavior dynamics of the data stream with low-cost probabilistic learning to output runtime suggestions to the use cases, like people counting, what the intensity at which data is consumed should be. This will reduce the data and give breathing space to the use case. Energy-aware model swapping, which swaps on the fly the employed AI model with another readily available but less complex model to harvest energy savings and satisfy latency guarantees when the compute resources availability of the edge AI service is limited. Let us examine use cases Savant configurations in the module sample YAML file. Notice that the AdaptoFlow configurations are currently commented out. By simply running the docker compose up command, the use case begins. The latter initiates the minimal execution of the people counting machine learning inference task and use case interface. Next, we'll update the Savant configurations to include the AdaptoFlow settings by creating the AdaptoFlow config.yaml. Additionally, we need to modify the Savant's configuration file. Specifically, we will introduce 6 lines of configurations. After making these changes, we rerun the docker compose up command, and everything operates as before. While running the minimal use case example, we collected metrics such as GPU power, GPU utilization, CPU power, and CPU utilization. Throughout this run, we conducted the experiment for 15 minutes, and the figures display the execution in fast forward. Using data from the use case partner's output, we pre-process it, set the number of cars as the target, and enable the AdaptoFlow adaptive inference service. Then, we rerun the experiment with AdaptoFlow's adaptive inference service enabled, capturing the same metrics as before. Notably, there's a reduction in CPU and GPU metrics. The figures show 2 dashboards, the left representing the default use case execution, and the right displaying the AdaptoFlow-enabled execution. We observed over a 50% reduction in resource utilization, both in GPU and CPU utilization, surpassing the KPI target of 30%. Additionally, we achieved approximately a 19% decrease in power consumption, exceeding the KPI goal of 20%. Finally, we calculated the results of both the standard use case and the adaptive sensing-enabled use case to compare their accuracy and data volume. The first plot illustrates the data points computed by the default use case execution. In the second plot, the red line indicates the AdaptoFlow execution results. The final plot displays both the adaptive, AdaptoFlow, and default executions of the use case. Evaluating the accuracy difference between the adaptive inference and the default execution, we found only a 7% degradation, well within the maximum KPI of 20%, while reducing the extracted data by 78%, exceeding the minimum KPI of 30%.